Hi friends, happy morning. Today we are going to discuss a new section in vector analysis, that is rotational metrics. What is rotation metrics, right? See, usually to describe one event we require a coordinate system. Maybe it is two-dimensional, three-dimensional, right? We require a coordinate system to represent a physical event, right? Now, suppose in that particular coordinate, suppose here one coordinate given, right? X and Y, right? So, in this particular coordinate, look here, I have a vector. That means that vector is any physical quantity, right? Maybe velocity, acceleration. So, that vector OA, so I am representing that as this vector OA, right? That vector is OA, right? This vector, how this vector affected by rotating my coordinates, right? So, initially, see, this particular vector, right? This particular vector making an angle alpha with the x-axis, right? Alpha with the x-axis. Now, that time I can write x is equal to, suppose this magnitude, suppose I am choosing the magnitude of this particular vector is r. Now, by considering this triangle, what is this x coordinate? R cos alpha, right? X is equal to r cos alpha, right? What about y? Y is equal to this y coordinate I can write as r sin alpha, right? This is a basic thing. Y is equal to r sin alpha, right? Now this particular vector r I can write as, maybe this is r dash. This r dash I can write as, right, x is equal to r cos alpha, y is equal to r sin alpha. So this is the x and y coordinate. Now suppose this particular axis, right, this coordinate rotate by an angle theta. That theta is mentioned here, right? This is rotating by an angle theta. So here if it x-axis rotated by an angle theta, definitely the same time y-axis also rotate, because x and y should be always perpendicular to each other, alright? So when x rotated by an angle theta, y also rotated by an angle theta. Now this vector based on this new coordinate x dash and y dash, after rotation x changed to x dash and y changed to y dash, alright. So what is the representation of this vector in this new coordinate system? That is very important, right? Now look here, with respect to new coordinate system, what is this angle? Alpha minus theta, right? Now what I can write about this? The new x dash I can write as r into, right, the magnitude of the vector is not changing, that is still magnitude is always r, right? So r cos alpha minus theta, right? R cos alpha minus theta. That means the old vector making alpha minus theta with the new x dash axis, alright? And what about y dash? Y dash is equal to r sin alpha minus theta. Understood? Alright. Now, using trigonometric equation, you can expand this. What is this? R cos of a minus b is cos a cos b plus sin a sin b, then sin alpha sin theta. Now what is this? I can write as x dash is equal to, this r cos alpha is already x, so x cos theta plus r sin alpha is already our y sin theta, right? Now regarding this equation, how we expand it? Y dash is equal to R sin alpha cos theta. Sin of A minus B is sin A cos B minus cos A sin B. Cos alpha, R is already here. Cos alpha, right, sin theta. Right. Now what is Y dash? R sin alpha is Y only. So first x coordinate we can write R cos alpha is x. So this term I am writing. So minus R sin R cos alpha is minus x. So minus x sin theta. Right. Plus second term, that is R sin alpha again y. Y cos theta. So this is equation 1, this is equation 2. Right. How we can represent these two equations in a matrix form? See, x dash y dash. So I am writing x dash y dash. Right. What is the coefficient? Here x, x. Here coefficient matrix are cos theta minus sin theta. Cos theta minus sin theta. Right. Here sin theta cos theta. Sin theta cos theta. Alright, into which matrix? Xx, here y, then y. So look here, what's the beauty of this concept? Look here, the new coordinates you write as the multiple of old coordinate with a matrix multiplication, right? That means using this matrix you can represent the old coordinate in terms of new coordinate, or new coordinate you can represent it in terms of old coordinate using this matrix. This particular matrix is called a rotational matrix, right? What is this matrix? Rotational matrix, right? Now suppose you want to write a xy from it. How you write it? Now look that one important thing is you have to remember here. We rotated anti-clockwise like this. Right. Axis is rotated anti-clockwise. If you rotate clockwise, what happen? Then you should take the inverse of this matrix. Then what happen to new x dash y dash? That is interchange this element. Then new x dash y dash you can write like this, interchange this element cos theta, and change the sign of diagonals, that is minus sin theta, right, into x, y. This is possible, right? So if it is rotating clockwise, this should be the expression. If it is rotating anti-clockwise, this should be the expression. That is very important. Right, we can do one problem, then you will get more idea. Alright? Alright. So I have already shown the derivation. This is the representation. Now look here. Here you have a beautiful problem. Look here. See, here the problem is find the vector which is obtained when the vector, one vector is given 1 by root 2 I cap, 1 by root 2 j cap is rotated 45 degree in counterclockwise direction. In counterclockwise direction. Counterclockwise means anti-clockwise. Who is rotating? The vector is rotating, not axis. In our theory, what we rotated? We rotated axis. Alright, we rotated axis. But here what we are going to rotate? This vector. Both are different, but we can think logically. Look here. So this is our old coordinate x, y. Now 1 by root 2 j cap, that means it is 45 degree, right? This is 1 by root 2 I cap plus 1 by root 2 j cap. That means this angle is 45 degree. Now this vector is rotating, see, this vector is rotating, look here, this vector is rotating anti-clockwise 45 degree. So vector is rotating, but we are unable to use our formula. We studied the coordinate rotating, right? This x is rotating, right? Like that only we studied. But think like this, if this vector is rotating anti-clockwise by 45 degree means that is equivalent to this axis is rotating, this is come and merging with this, that is equivalent to this is coming and merging this. So this is equal to this y axis is rotating y dash, alright, and then axis is rotating 45 degree like this, right. So the vector is rotating counterclockwise 45 degree, that is equivalent to the y-axis or the entire coordinate is rotating 45 degree in clockwise direction. Both are equivalent cases. So if anti-clockwise rotation you studied the formula, and clockwise rotation what we studied, rotation matrix, our new coordinates, right, x dash y dash what we studied equal to cos theta minus sin theta come here, right, clockwise, anti-clockwise here plus sin theta, here minus sin theta, remember that, into, right, xy. What is the x dash y dash? This is the new vector representing the coordinator, and here all the angle is 45 degree, right, because 45 degree rotating. Then this is 1 by root 2, this is again minus 1 by root 2, again 1 by root 2, here 1 by root 2, here xy that is given, this is our xi cap plus yj cap, right, that vector, that is 1 by root 2, right, 1 by root 2. Now what is x dash y dash? You can simply write 1 by root 2, 1 by root 2, 1 by 2 minus 1 by 2, that is 0, right, here 1 by root 2 into 1 by root 2, 1 by 2 plus 1 by root 2 into 1 by root 2, again 1 by 2, 1 by 2 plus 1 by 2, 1. Then what is the final vector you got? This is 0, 1 representing 0 I cap plus 1 j cap. Then you got j cap, correct only. See, look here, now this is the new x dash axis, this is y dash axis. Now the vector is the axis is rotated and coincide with our old vector. Now vector is in the direction of y axis, new y axis, that means j cap only, right. It's a beauty, alright, alright. So this is all about this section, and our vector analysis discussion almost completed. Now during the coming sections we will discuss previous year's questions from this section asked. Alright, okay, thank you.